Well, thanks very much. This is actually a change from the scheduled talk. I'll be giving my technical talk on narrative-based dungeon design tomorrow. But I thought, following on from Darren's talk, I would just give you a little bit of a narrative about what I've been doing over the last couple of weeks. Now, if you see a talk or a paper that starts towards, it's sometimes said that the person giving the talk or writing the paper has made absolutely no progress whatsoever. So I shall leave you to judge once you see my talk. So, who am I and what do I do? Well, I do other things other than roguelikes, but I thought I'd focus on the roguelikes for this slide. I maintain at the moment, I think this has a laser pointer, yes. I maintain at the moment a web interface to the game Rogue, which is located here at this URL. So you can go play online, have your high scores up, observe and chat to other people. So do check it out, particularly if you haven't played Rogue. It's a great quick introduction to what is a really brilliant game, which I have nothing to do with, I hasten to add. Other things I have done recently, I wrote a commercial roguelike-ish on Android about 5 years ago, and I've done a number of 7 DRLs. These two, Princess RL and Trauma RL, were somewhat popular on the roguelike scene. I like Trauma RL as my best work, I think. You can find my games here at flen.net and soamigames.net. Okay, so where did this talk come from? Well, I was looking around one of our favourite subreddits a month or so ago, and somebody asked this very good question. Anyone played with deep learning technologies to generate maps? I thought, well, that's interesting. I've heard about deep learning on the TV. I like generating maps, so maybe this is something I should look into. And there were 4 comments, and people said, like, it's a bad idea, don't do it, you'll need these things. All very reasonable pieces of feedback, actually. But I thought, there's a couple of weeks before the conference, I'll see if I can learn a little bit about deep learning and see if we can use it to generate roguelike maps. So what is deep learning? That was the first question I had to get my head around. So I looked at the news, and it's something to do with AI becoming more alien, according to Rory Cellan-Jones at the BBC, because it can beat us at Go better. It's something that's going to steal jobs from our children and candy as well. And it's something that represents a fundamental risk to the existence of Tesla, according to Elon Musk. So obviously it's not a very good thing, but if I can use it to make good roguelike maps, I think I'll let it off. Of course, we all know where it ends. So let's go to Wikipedia and see if we can find a slightly more rational description of deep learning. Well, it's a field of I think the Terminator is coming for us. Yeah. This is top secret information I do not want you to know from the future, right? So it's a field of machine learning that uses a cascade of multiple layers of nonlinear processing units for feature extraction and transformation. Each successive layer uses the output from a previous layer as input, and it learns multiple levels of representation that correspond to different levels of abstraction, the levels forming a hierarchy of concepts. So there's a lot of words there, but it sort of makes sense. It means it's a learning technique that can by itself figure out what are the interesting things in what it's looking at. So if you're looking at images, as we will in a sec, maybe it's something about looking at edges or looking at faces. And it's something about having multiple levels, simple things building into more complicated things, and that's where the deep comes from. And as far as I can see from the literature, it's been something that's been around probably since the 70s, but it's really come back into the sort of scientific eye in the last 5 or 10 years, because technology's got better and we literally have the technological tools to do more of this, and therefore people have been researching it more and have found a number of breakthroughs in terms of training networks, in terms of using them. So here's an example of a deep neural network and how it might be used. And I've taken the example here of what's called classification. So it's figuring out what something is in an image. So you start with an input layer. And in my example, this is my input layer. So it's literally the values of the pixels that make up this picture. Row by row, that's what we're feeding into the neural network. Then we have a series of hidden layers. These are the parts of a neural network. Each of these blobs you could think of like a neuron in your brain. These are the bits that do the real work, and we train them. Basically, they train themselves to answer the questions we ask them. Each neuron has a number of inputs, which comes from all of the neurons or some of the neurons in the previous level. So you can see this is about the sort of multi-level learning or taking inputs from each progressive layer in order to do more sophisticated things. And then you've got an output at the end. And in the simple case I've got here, the question we're trying to train the network on is this a cat or a dog? Any guesses? Yeah, I think it's my neural network says it's a dog, but I'm not really an animal person. And the output would be dog or cat, or 1 or 0, because it's computers, you know. And this was a problem, 3 or 4 years ago, which was really taxing the state of the art. If you were Kaggle competitions, Kaggle's like a data science machine learning competitive website, from about 3 or 4 years ago, where people are doing their very best and getting like 90% or so classification. In the last few years, people have done much, much, much better. Right, so I've sort of given you an idea of the question, but how do we actually go about training our network to be able to give us an answer? Well, we use something called supervised learning. So we supply many examples of an image and what it is to the neural network, and then use something called backpropagation in order, and stochastic gradient descent, in order for it basically to train itself to get better at providing the right answer. So we give it what we call a training set, a lot of images, and whether it's a cat or a dog. So here from Kaggle I've pulled out, or somebody has pulled out, a series of pictures of cats and pictures of dogs, and those are fed into the network, and it starts to learn how do we distinguish a cat from a dog. And if you think about it, it's not completely straightforward, right? Because cats come in lots of shapes and sizes, and dogs come in lots of shapes and sizes too. And again, I'm not an animal person. But if I was a neural network, I might think, well, pointy ears are a pretty good indication of a cat, and maybe this kind of coloring, that's kind of a bit cat-like. Dogs, big floppy ears, baleful looking eyes, that kind of more spotty pattern, a bit like a cow. Again, not an animal person. That's kind of indicative of a dog, okay? And so broadly, we use something called a convolutional neural network, and broadly, it starts to learn those features. So let's go back to this idea of multiple hidden layers. Well, here, this good paper down here, and throughout the talk I'll be citing the sources down below, so please do go and have a look if you're interested. In this source, it gives us some idea in a convolutional neural network, what do each of the levels do? So, without going into too many details, the first layer here is sensitive to these kind of patterns. So it's sensitive to edges, it's sensitive to different gradients, and bear in mind when I'm talking about this, we didn't tell the neural network to do this. It learnt itself that these are useful things to pick out of images. Okay, and that's about the automated feature extraction I mentioned right at the beginning. It's slightly harder to see here, so I hope you can, but the later layers take these kind of outputs as input and then start putting them together. For example, they've started looking for things that look a bit circular. And these ones it's hard to see, but these are sort of like diagonal stripes that look a bit like fur, or vertical stripes or horizontal stripes. So as the layers of the neural network progress, it moves from finding very simple things into finding more complicated textures. And in some papers, as you go further and further, the really late levels start looking for things that look like dog or cat faces, which they've built up from the output of all these filters, all these convolutions before. So there's an extremely high and quick level view on classification, which is something that neural networks are used for a lot. But can we sort of go the other way around? We've gone from an image to whether it's a cat or a dog, or even what type of cat or dog it is. Can we turn those networks the other way around, put in something simple, and get out an image? And this is an active area of research as well, which might be known as, say, a generative network. And surprisingly, at least it surprised me, the answer is yes. The literature seems to concentrate on a number of different classes of things they've tried to generate. I'm going to show you just a couple of examples. So bedrooms seem to be really popular, believe it or not. So the reason is there's a big data set where somebody's taken about 3 million pictures of bedrooms. So what they've done, without going into too many details, is they fed all of these pictures of bedrooms into a neural network, and then they've got the neural network to make what it thinks are plausible bedrooms. Now, these are not real bedrooms. These are not members of a training set. They're not the photos that were fed in, but the neural network has learnt to find things which are bedroom-like and then build its own images. And if you think about that, it's quite incredible. You know, this is what sort of got me excited about the idea of deep learning. The fact that a neural network can go from basically nothing, basically random numbers, much as we're used to in procedural level generation in roguelikes, into these very complicated things, very complicated images. And if you look at, you know, this one or this one, then you think, yeah, you know, I could base a bedroom on that. I wouldn't mind living there. I wouldn't mind sleeping there. It doesn't always work. I mean, this looks like some sort of post-apocalyptic nightmare. But generally, it's really very, very good. And again, there's a source down there if you're interested. So another thing that, again, I saw on Reddit, which I was blown away by, was generating cartoon faces. And if I can get the technology to work, I will show you this website, which you can check out later. So this website called Make Girls Moe allows you to select some characteristics of the face you would like. Let's say brown, long hair, and blue eyes. Then hit generate, and it uses the neural networks we're talking about to make a completely novel, new image, new cartoon face image. And again, not a member of a training set. Now, I could not draw this well, and certainly not this quickly. And not all the images are, 100% perfect, but it's a really amazing example of how you can use neural networks to create arbitrary, or at least semi-arbitrary, image outputs. And as I say, you can just go to this website, put together by this group of Chinese postdocs, I think, and play around with it. And I think you'll be really impressed by the functionality of these networks nowadays. So, roguelikes. Tomorrow I'm going to talk about narrative dungeon generation. And I'm not using any neural networks or anything like that. I'm using standard procedural generation heuristics, which anyone who's built a roguelike map generator will be quite familiar with. I've got a particular problem, which I'll show you tomorrow, where I'd like to say, give me a dungeon layout which looks kind of cavey, but has a large loop in it, and a couple of secret rooms. Now, where I'm coming from, that's not dissimilar to what I just showed you on the web, where we could say, draw me a face with brown hair, blue eyes, and a ribbon or something. So I'm wondering, which is what I've been playing with over the last week or so, can the same technology which is doing the bedrooms and doing the cartoon faces be used in roguelikes? And that's the question that I think that poster was asking a couple of months ago on Reddit. So before I go there, I'll just try to give you a little bit of understanding, and I, of course, only have a little bit of understanding myself in terms of how these generative networks work. So the trick with the generative adversarial networks, or GANs, is that we have two different neural networks which are basically played off against each other. So we start with a discriminator network. And what's its job? Its job is to distinguish a fake image from a real image. So again, here I've got a picture of a dog. That's a real image. And I've got a picture of a fake image. Well, this is just a noise field, which is what you might start with. And you train the discriminator network a little bit to understand or to be able to distinguish real dog, a library of real images, from something that's fake. Okay? And I think most of us could distinguish that from that pretty straightforwardly. And then what do? Well, you train a generative network, a generator network, to go from just a random input, just some noise, into a picture of something it thinks looks like a dog. You see, it's done pretty well here. That would be about my level, I think. But you're going to ask, well, look, this is a random network. You started off with, let's say, random weights. So it's a randomly set up neural network. And you're feeding in random noise. How do I get to a beautiful picture of a dog like that? And the trick is you play the generator network off against discriminator network. So the generator network makes a picture it thinks looks like a dog. And the discriminator will say, that's not a dog. That's not a dog. And eventually the generator network, by luck, will get something that looks a bit dog-like. And the discriminator network will be, maybe that is a real dog. In which case, the generator network knows it's done something good and should do more of that. And eventually you get to a point where the generator network's producing things which maybe look like this. And because we've only trained our discriminator network a little bit earlier on, it can't tell them apart from a real dog. So what do you do then? You train the discriminator network a bit more. So it identifies things that look like aliens with 5 eyes are not real dogs, whereas these things are real dogs. And then you set the generator network trying to trick the discriminator network, and it will quickly learn that things with 5 eyes that look like aliens aren't really like dogs. So you play these two networks off against each other, and there's lots of complex maths involved and loss functions and infinities and all that kind of stuff. But fortunately, somebody's done that for us, so we don't need to worry about it too much. And you can train a network to generate arbitrary images if you've got a set of images you'd like it to produce images which are similar to. I'd say it's a bit like a currency faker trying to beat a policeman. He might come up with some reasonable fakes at the beginning. The policeman's not sure, so he needs to go and buy a new microscope or something to tell them apart, in which case the faker ups his game and produces a better fake, and the policeman then has to up his game. It's a similar sort of idea. So, bringing us back to the world of roguelikes, can we use these things? Can we use these generative adversarial networks for dungeon generation? So, what I tried to do over the last week or so is to train a GAN to create random dungeons that could pass as a real dungeon layout, and therefore be high enough quality for use in my generators. So, I've only done simple experiments so far, but I've started with examples of a dungeon layout, and I've tried to train a GAN to produce its own original versions. So this is the first experiment I did with cave systems. I created 2,000 cave-like systems using an established generator, which is this one, from a rot.js library. Here you'll see a couple of examples. They look a little bit odd because I've asked it to create connected levels, so all the grey areas are connected to all the little islands through these little links. And I trained a GAN on my computer. I had to swap my graphics card out for one that can do this overnight to create its own cellular dungeons. So this is an animation over 4,000 iterations between the generator and discriminator on how the output of the generator looked. So you can see it starts with quite a lot of noise, quite a lot of square artifacts. And as it goes along, it starts understanding how the features of these cellular dungeons ought to look. And when I came back in the morning, after 4,000 training epochs, it starts producing something that looks relatively reasonable. So I haven't cherry-picked these particularly, in fact at all. Here are some training dungeons. So they're from the original generator. And here's some completely original dungeons that the neural network has built by itself. And actually you can see it's done, from my very crude experiment, a pretty decent job. It's got a lot of grey areas that look kind of similar. It's even kind of learnt that connecting things up is a good idea with these little bridges. It's not completely perfect. I could probably distinguish that from that. Particularly, it tends to fuzz out the areas, the edges a little bit. But you can see, you know, I could play a game in that. Would be reasonably respectable with a bit of cherry picking. Second one, a bit more challenging. I tried to train a GAN, which took a day and a half, to create its own dungeon maps. So these, again, this is not necessarily a dungeon I'd really want to play. There's a lot of corridors in here. It comes from a ROT.js dungeon map generator this time. But you can see it's a more challenging target. It's got a less organic, coarse-grained feel. So I was interested to see if a generator, a neural network, could build something like this. It took a lot longer, and you can see the progress of the training of what it produces through here. A kind of interesting one, this one. It starts with noise, then some squarey things. It starts looking good, then it sort of regresses a bit. There's nothing saying that it always should get better, as I understand it. And eventually we get something that looks okay. So again, on the top here, I've got training dungeons. Here, I've got some generated dungeons. These are original dungeons that neural networks produced. It's not bad. It's kind of figured out the blocks and line thing. It's got that going on. Sometimes it tends to make little isolated islands, which aren't quite joined up. And to be fair, I have cherry-picked out of 20 images. Last night, I took 3 that I thought looked reasonable. So these are some of the better images it produces. It tends to suffer a little bit from not perhaps filling in enough of a map sometimes. So those are my experiments over the last week, just to see if we could get towards roguelike dungeon generators using this technique of neural networks. So very early results. I told you it took overnight to actually build these neural networks. That's true for the training, but the generation itself is really fast. So my desktop, in a fraction of a second, can produce 50 of these. So it's definitely fast enough for game applications. You saw that on my website as well. Training the cartoon face generator must have taken weeks, but actually generating a new face took a few seconds. I'd say the quality isn't quite up there for applications yet. The cellular dungeons seem to be easier, and the connectivity, as I said, isn't quite learnt in the dungeon case. So I think there's probably some stuff we can do there, trying to push the neural network towards making connected dungeons by putting a penalty into the training if it's not connecting its dungeons up. So very early days, just really to see if it worked. I think there's enough hints there to suggest that in future this might be a technology which is interesting for us. I would try and improve the quality through longer training, different neural network architectures I haven't gone into today. One of the things I started with I want to get to, if I do use this technique, is to be able to specify features like a big loop, like blue eyes, for example. I'd like to try training with mixed maps. So I trained with the cellular ones, I trained with the dungeon ones. I'd like to try and train with both to see if it created some sort of interesting hybrid of the two. Other things we could use this for, well, I'm sure it's going to be very good at training to produce things like Perlin noise, which we're quite used to in roguelike terrain generation. But there is a fundamental sort of issue here, which is I'm training a neural network to produce things that look much like something I've already got. So to be really interesting, I need some examples of things that I can't generate myself at the moment. So, for example, I was thinking you could take some real-life terrain maps, maybe zoomed out photo images. If we could classify those into different types of terrain and then use a generator to learn from those, we could make something that would produce realistic-looking overworld maps, for example. But the quality of some of the examples which are out me encourages me that this could be a promising technique in the long run. It's certainly not going to take over from traditional roguelike dungeon generation algorithms tomorrow, but an interesting, I think, line of work. So, as I say, I've only been looking into this for a couple of weeks, and everything I know came from these free courses online. If anyone is interested in deep learning, these are fantastic courses which really take you from I'm a coder who's interested in this to I'm able to use a GAN, for example, to to focus on a novel application, or I take these image classification algorithms and focus on a novel application. So a really good way of getting up to speed really quickly. And that is the end of my talk, so thank you very much. Hi.
I'm sorry if this is maybe a basic question. I don't know much about roguelikes. How do they generate the dungeons now?
Okay, so
Sets of rules that they connect.
So the question was, in roguelikes at the moment, what techniques are used for creating maps? So the answer is there's a variety. I'll be discussing it a little bit tomorrow. But typical algorithms include taking templates for rooms, scattering them randomly, and then joining them up with corridors. Sort of digging algorithms, where you have which is like the cellular example I showed you, where you start with a completely filled in map, and you train something which will dig around neighboring squares randomly up to a point. So you get sort of Doug-like environments. And there's some techniques using things like binary space partition trees, where you cut the level up into chunks, put a room in each chunk, and then join them up into a sort of tree. So a variety of heuristic-spaced approaches. But to my knowledge, I don't think anyone's tried to use a neural network to do this to date.
Just go back to the slide that you generated the rooms. Yeah, so if you take a look here on the upper three images, there is a lot of corridors that curve a lot. And down below, there isn't so many of them. Rooms are mostly joined by straightforward corridors. So what would you hope to achieve by using neural networks? Is it just like a test, or do you have a specific goal in mind?
Sure. So what I'd like to do is I'd like to say I would like a map which overall has a big loop in it, maybe has a few smaller loops, and looks like a dungeon. So there are some papers where people have started with, let's say, some images of birds, and they've trained a neural network to caption them, to say, this is a red bird with blue feathers, for example. And similarly, then they've taken those captions and asked it to generate an image, and it can generate more or less an original picture of a bird with those characteristics. So I'd like to be able to create somehow some of these typical dungeons, perhaps by hand, if I had enough time, to say these are the kind of dungeons with loops that I would like, these are the kind of dungeons with secret rooms, and then I'd like to train a generator which could take all that information and build up a whole heap of, or an infinite number of original dungeon designs to use in my game. I would probably put it on hold now, I think, and see where the field goes. So the code I used to build this comes from a paper that was released in March. So really, it's actually sort of bleeding edge stuff. I think it's sort of into diminishing returns now. There's a few things I'd like to do, but if I leave it another year or two, I think the field will have advanced sufficiently, but I might have a much easier job at actually using this for a practical application. Darren.
So I guess I just want to work at data science, where we develop machine learning as myself, but fair amount of knowledge.
Okay, so Darren is an expert. Go ahead, Darren.
So I could probably spend several hours talking about this, maybe later. But I guess, the big challenge for you here is the training set.
Yes.
That you need a large enough data set to perform deep learning on, but you also want the right quality features in there.
Yes.
To get that, you need to create the algorithm that you want at the end anyway.
Yes and no. So the question is really, Tom, you're trying to do something completely circular here. You'll need to actually build a training set which is good enough that basically has everything you want in it in order to train your neural network to produce what you want. So my hope is, based on my limited understanding of the technology, if I was to create training sets which had, let's say, a lot of big loops, and another training set which had interesting arrangements of secret rooms, and used a conditional GAN, like in the cartoon face examples, then the network would be able to make original combinations of them. For example, in the cartoon face example, there may not have been many or indeed any samples which had green hair, long hair, a ribbon and glasses, and yet it is able to make an attempt at producing that. So by using a categorical approach, I hope I can build things that aren't in the training set with features I want. But yes, you're absolutely right. And as the Reddit guys said originally, the big challenge here is producing a training set, which gives you something that you want without actually having the ability to generate it anyway. And again, that's why the real-world examples, terrain, for example, might also be a way of getting around that. I can't generate realistic-looking terrain, but a world is full of realistic terrain.
So, I mean, one thing you're going to need there is label data. So currently you've just got dungeons and caves. You're only two labels that you've got. You want to do just pretty much a label thing. So maybe if this is the way that it had green hair, someone went through that data and identified green hair, so they could feed that data in and be able to build that. You'd have to find a way to label your data appropriately so that it's identifying the right features.
Yeah, so again, the question is, well, how do you go about labeling the features in your training set? I would have to build some simple algorithms to make big loops, some simple algorithms to make dungeons with secret rooms in the way I wanted. And then I would have the labels because they come from a generator algorithm. And I would hope that the GAN would be able to combine those in novel ways. So that's the value I'm getting at. Yeah, you could use some heuristics to identify the types of features you wanted in an algorithm which generated a lot of diversity, and just select for those. That would be a good approach. But again, we'd need a algorithm which produced a lot of diversity. So I'd need to be able to, for example, using this algorithm, for example, only find an algorithm that could only select the most loopy pictures and then use those to train the GAN. Yeah, so the question is, am I doing this entirely image-based, to which I'll answer a suspicious yes.
So, I mean, have you looked at creating a system that's producing non-image, that's producing process?
Okay, so the question is, could we use something like reinforcement learning where you don't have labeled data to build processes? No, it's an interesting idea. I've not looked into it. It would depend on the availability of source code, which I could rapidly try, I think. Question there?
Yeah, so you mentioned that the output is really fast in on the slides. So how much faster is that?
So the question was, how quick is the output? So I haven't timed it, but pressing Shift-Enter on the cell that does the creation for creating about 200 novel dungeons is almost real time. So it's going to be in the small number of milliseconds for these, I think, 64 by 64 grids. So it's actually a lot faster than some of the heuristics I use in my actual games. And that's just on the CPU, that's not on the GPU. Okay. Oh, another question there?
Yeah, I have I'm sorry if I missed this. I don't think I said. Could you give me a ballpark estimate of the complexity of the neural network?
Yeah, that's a good question. I didn't put up any neural network architecture slides. So from memory, these had about, the generator had about 10 layers, 10 different convolutional layers, each one with 64 features. And the input size was 64 by 64. But I can show you the source code later if you'd like to probe into the architecture a bit. I did try some different architectures. For example, deconvolution versus upsampling, which is meant to improve the output, and tried some different non-linearities in the output layer to get something that looked a bit more binary, but I didn't really get noticeably better results. Darren.
The other area where deep learning in using gaming is bots or AI components. Have you looked at any of that?
No, so the question was, how about deep learning for bots? Again, I think it's really interesting. Certainly the Atari 2600 games seem to be a target, a published target, and DeepMind, for example, are using reinforcement learning to build super human bots which can play arbitrary games. I guess, of course, we've all played against bots in Counter-Strike, so we know that they can be better than humans. But when reinforcement learning, you can take a video game a neural network's not seen before, tell it where the score is, and tell it what the controls are, and let it get on with it, and it will learn like a human learns to play the games, and they will play better than humans after a particular amount of training. There's a company called DeepMind, which was bought by Google in London, who seem to be doing a lot of this research. But again, yeah, I would really love to see an Angband bot made with deep learning. It'd be interesting to think about the fact that roguelike games are very long. You would probably need to say, okay, that these are sort of incrementally good moves. You wouldn't want to run a bot to play the whole of Angband every time just to say whether it's getting better. You would need to say, okay, for example, as your HP or MP go up, at the rate at which that goes up, that defines what good moves are, or making progress to a lower level, for example. So lots of interesting things there. Another thing people do use these generative networks for is generating text. So the idea of generating procedural stories or even simple things like names is definitely something that's possible at the moment, which would have applications into our games. Cool. Okay, if there's no further questions, thanks very much.